Okay. So today we talk about advanced query with I, analyzing data with ink. We have talked with Spark and Scala fundamentals. So next week is going to be like our final class. So, but next week we are going to it's going to be more of like practical and practice questions. So,
Okay.
so we're going to do practice on how then look at some useful websites where we can upgrade our knowledge in R and about the purposes of.
So what you're trying to say now is that we are going to finish this. What about today? This book today. Huh?
Hopefully.
5 and 6, 5, 6, 7. Okay, no, the other one is Spark competition.
That is bonus session always.
Yeah, okay. Okay, I think I'll find this one very interesting. Yeah.
Which one is that?
It's, I don't know, it's not bad. It's part of SQL and all that. So. Yeah.
Okay, you use SQL.
Yes.
Interesting. All right. So this session we look at SQL commands. My voice is echoing.
Your voice is what?
My voice echoing.
Manage it, we don't have a choice.
Hello.
Dr. Harvey, good morning.
Good morning.
Morning, sir.
How you doing?
I'm good, and you? How's your week?
Very well. Sorry, I'm a little late for the class.
You're not now, Abba. It's just 10 minutes. We just launched this now.
Okay.
Yes, sir.
How's the family, Susan?
Very well.
Okay. Ima, how you doing?
I'm fine, sir. How are you, sir?
Very well, we thank God.
Okay. All right, welcome, sir.
Thank you.
So today we want to talk about advanced query with Hive. That we will start. So hopefully you are seeing whether sir. Sir, I didn't hear that, sir. Susan, can you hear me?
Yes, I can.
Okay. So we are going to try to cover HQL. HQL is a like Hive QL. So the extension for Hive scripts, like you have in MySQL or all these relational database, all their scripts is inclusive by .sql. So we are going to learn the HQL command to perform DML queries, data manipulation language, implement joins, perform performance tuning and query optimization in Hive, explain various execution types. Okay. So let's just get started. It's just 2 slides here. So Hive query language, which we know as HQL, are written to perform database operations in Hive. So the most common type of HQL query is the select statement, which is what we know very well. We are very familiar with select statements. Do it every day. We write SQL scripts. You can't do with select statements, but usually that's the power of an analyst, power of select statement. So apart from select statement, the other important type of queries are inputs, nested queries, that we write select inside, not select inside, not select. Case statements, the like and the like queries, like regular expression, like group by queries. Yeah. So you have the select statements, which is, as you can see on our screen here, select column 1, column 2 from a particular table. So this one is saying that, okay, I want to call column 1 and column 2 from this particular table called table underscore name. And this one is like select records from column starting with a given string. Okay, this one says select string star from table name. So this one is saying that, okay, any column that starts with this particular word string in my table, select it for me. And this one here is saying select everything from this table, but limit my query or my records by 10. Just give me 10 records out of this particular table. But give me everything, all the columns. Okay. Let's go to the next slide. Can we go to the next slide?
I hope you are recording.
Yes, sir.
Okay.
So you have nested queries here. Nested queries here. So this one is saying, okay, select star from a particular table name, say employee table. Now I have a where condition which compares this. So which compares select column from table name. So this one I can write something like maybe select star from employees, or now say where salary equals select salary from table name, maybe a particular table. So this is kind of do comparison check. Okay, I can say, okay, select salary from table name, or select star from table name, select everything from my employee table. I will now say, okay, where salary greater than select salary from employee, where employee name is Dr. Aben. So this one is saying that, okay, give me all the information of salary of employees in the employee table, where the salary is greater than the salary of Dr. Aben. So it's going to give me an employee that earns more than Dr. Aben. I'm sorry for using that example.
No, it's good. It's good, Ima. Because we're on the minimum wage, so you can use us, no problem. It's only Susan that will not feel comfortable.
No. So we have also the case statement here. Now this one is saying, okay, maybe select a particular column, say employee. Then I will say, okay, select. Now I will say case when particular condition, then do this. So when the condition is met, then do this. Then I can say, if I'm not ending my query yet, I can continue again. When this second condition, then do this. Else, that is, if these first and two conditions are not met, then do this final statement that is inside the else. Then I will say end as, then give it that particular case statement a column name called maybe salary range. Then from a particular table, say employee. So let me explain. So let's say I have a particular table. Then I want to group my employees based on the salary they earn. So let's say the minimum salary you can have in that company is 100,000. Then maximum salary is 500,000. So maybe I want to group, okay, people that are earning between 100,000 and 200,000 as low salary. People earning between 200,000 and 300,000 or 400,000 as medium salary. So let me say people earning above 400,000 is now high salary. So I will say, okay, I can say select employee name or first name, comma last name. Then first now group, I will say case when salary between 100 and 200,000. Then I will say I'll put a particular string, say low salary. Then I'll continue when salary between 200,000 and 400,000. Then put a string to identify that particular role as what medium salary or average salary. Then I'll say else. So if those two conditions are not met, it's going to take the last option, which is greater than 400,000. But you can still explicitly specify it. But this else just say, okay, apart from these two conditions, whatever happens, like if a particular rule does not satisfy any of these two conditions, then do this. So else I'll say high salary. Then end as, I'll give you the column name called salary range from employee table. So that's an example of what a case statement. Okay, let's look at like and like queries. And I will say, for this example, I have select star from the particular table, and I'll say where column 1 like this, where column 1 like this. So look at this particular expression after the like. Now, if you want to use like, there's something we call white cards. So there are different white cards you can use. So using this kind of, so we have percentage, we have what is this underscore, yeah, we have this underscore. When it comes to just like, I think we have like 3 of them. So what this one is doing is that, okay, let's say, okay, I want information about an particular employee in the employee table where their job title is like, there's analyst inside their job title, say analyst, maybe data analyst, maybe research analyst, something like that. So I want to get information about all these people. I'll say, okay, so let's start from employees table where job title, like, then I'll put percentage at the front here, in quotes, percentage at the end, then I'll put analyst inside. So this is going to find any job title that there is the word analyst inside the string. So whenever you find analyst inside the string, the thing is going to extract that information for you. Then also the R like here is like okay, maybe we see a perfect example of what this one actually means, because I think we have seen something like this star and this star. So if the star maybe is at the back, you see it starts with, but then we are going to, they also use white cards also, but the way they work, it's more dynamic than the normal like operator. But I think we are going to see as we proceed. So let's look at group by queries. Now, group by queries, this is the way they work. So let's say you have the employees table. I will still use the employees table. Now, in a particular company or organization, we have different departments. Now, suppose that you want to find the the salary or the average salary of employees in their respective departments. Now, it means you want to do something like select average salary from employees, then you say group by department. So in that case, it's going to give you average salary of employees for each department. So if you have 10 departments, it's going to give you 10 averages. That will correspond to each department. So what group by does is that it works with what we call the aggregating functions. So you might not necessarily use it with aggregating function, but it's mostly used with aggregating function. So you can say, okay, I don't want average. I want to find the number of employees that exist in each department. So in that case, I can use what we call count function, which is part of the aggregating function. So so you have like, I think we have like 5 aggregating functions. You have the count, you have the sum, you have the average, the minimum, and the maximum. So I can say select count star. You can use count star from employees, then group by department. Department ID, maybe that's what is the department, that's the ID that is common to both employee and department table. So if I say group by department ID, that should give me the number of employees that exist in each department. So that's how group by queries work. Then having queries, call it having clause. So you use having with group by. You use the having clause with the group by clause. So instead of using the where clause, after a group by statement, you cannot put a where clause. No, instead of using a where clause, you are going to use the having clause. So the having clause works after you have done your group by. So let's say you have done select average salary from employee, you have group by department, but then you still want to put some specific condition to those results. So you can say, okay, maybe you don't need the average salary of department that are less than 200,000. So you can put that having condition there. You now say having average salary greater than 200,000. So that will limit your roles, not your query, not to return department that are average salary that are less than what 200,000. So that is using having clause for you. So because you cannot use where clause after the group, but you can only use having clause. So that is also I think I've explained that at this level. Do we have any question before we proceed to the next slide?
Iman?
Sir?
Iman? The break in audio, is it from your side or from my side?
Breaking. Okay, let me ask Susan. Susan,
Susan, do you experience breaks?
No.
Okay, it might be from my side, but I don't understand why it had to be so.
Okay.
Okay.
Susan, you can proceed, right?
Yes.
Yeah.
Okay. Now, manipulating columns values using function. You have the built-in function, you have user-defined function. So the built-in functions are the ones that are inbuilt in a database management system. So you have like the count, like the average, like the minimum that comes with it. So the user-defined functions are the ones you specially designed for some specific tasks for yourself. So with inside your user-defined function, you can even use an inbuilt function, just like creating functions in R too. So some functions might not be able to solve the problem you want to solve. So you might have to design another function for yourself using even some inbuilt function and combine it together to achieve a specific task. So that's the essence of having a user-defined function. Now, built-in functions in R, we have the arithmetic function, mathematical function, the aggregate functions. So let's say look at this. I don't know why they call this an aggregate function. It's upper and aggregate. It is well. So this one says select count star from table name. So what this one is going to give you is the number of records you have in that particular table. That's what select count star will give you. And select, if I say select average column from a particular table, this is going to give you the average of that particular column. It's a single row query. It's going to give you a single result unless you're using a group by plus with it. So if I say select average salary of employees in a particular organization, it's going to take the salary of all the employees in that organization together and give you the average, which is going to be a single result anyway. Also, the upper function. The upper function is used with character or string. You just convert to uppercase. So if I have a particular character, say in lowercase, it's going to convert it to uppercase, everything to uppercase. Okay. Let's look at user-defined function. So creating user-defined function requires writing Java classes and overriding the evaluate method, which is part of object. So you writing user-defined function now is saying that you have to write it in Java. But if you have to write Java, then it might be a little bit difficult doing that. But if you are in your relational database management system like my SQL or Oracle, it's quite easy to write user-defined functions to achieve the task. So probably in R might not be that easy and straightforward. But you say creation. First of all, the steps involved in this process are creation of a Java class, the creation of a Java file from the class, creation of a function from the Java file, So, and the Java file created in the previous steps. So these are the steps. So add the Java file to Hive. So this one says add Java. So put the location of the Java file, then slash specify the Java file name. Then here you're going to create the user defined function, say to uppercase. So you want to create the user defined function, which is to convert something to uppercase. So you can see here, create temporary function. I think it's temporary, you want to create it to upper as. Then you're going to specify the Java class you have created. So first of all, put the location. This is the part of where you see dot the class name. So that should be the Java file name. Then after you run this, then you are going to use the user defined function. So I think after you've written this, then you can now use the user defined function that you have created. Say select to upper particular table. Maybe if you are interested in writing that kind of function, we can read about it, but probably we can see next slide. So let's talk about joins in array. So everything here is not really different from the normal relational database. They are the same task. So types of functions in array, I think this will be types of joins. You have inner join, then we have outer join, then you have cross join. So the outer join, we have the left outer, the right outer join, and the full outer join. Now, the inner join, this is how the inner join works. You have a table A and a table B. If you are doing inner join A on B, it joins both tables based on two columns from each, like a particular column from table A and another particular column from table B that has have something in common that you can match them together. So let's say you have employee and the department table now. Employee table has what we call department ID, and your department table is going to have what we call department ID too. So there's a way you can join employees with department table using what the department ID. So if I want to do an inner join on it, then it's going to join both of them based on the department ID that matches in both tables. So what that one is going to do is that it's going to give you employees in the employee table, and it's just like you want to get the department of each employees in the employees table. So that's the logic there. So you can get the respective department of each employees in the employees table using inner join. Now, if you say left outer join, let's say table A is the one to the left now, and table B is the one to the right. Let's say table A is the employees table, while table B is the department table. Now, if I'm doing a left join on employee, which is the guy at the left, all records in employees will be selected. Then it will be matched with what the department table based on the columns that are common to both of them, say the department ID. So what will that give you is that it's going to select everything in the employees table and match it with what's the department table. Select everything in the employees table and matches it with what is common to the department table. Don't forget employees to the left and while departments to the right. It's very essential. We're doing left outer join. Everything is in the left is being returned, then matches with what is at the right. So in that case, I'm going to have the records of employees and their respective department. But it's possible a particular employee does not belong to a particular department. So in that case, I'm going to have no values as regards department of that person that is in the place because everything in the employees will be selected. So if the particular employee does not have a department, then in that instance, there's nothing I can use to match employee with the department table. So in that regard, the department of that guy in the employees table is going to be null because there is no match. So in the case of a right join, every rows in the table to the right will be selected. Then it's going to match it with everything with the tables at the left, with the table at the left. Now in this case, let's say the department type table is also the guy at the right, while the employees are at the left. Now all the departments will be selected. Then it's going to match it with what? The employees table. And in case whereby a particular department does not have an employee in it, maybe the department is new and there is no employee that was employed into that department. So it implies that department is not going to have an employee. Right? So that is right outer join. Then full outer join. Full outer join is that select everything to the left, select everything to the right, then join it based on what matches, which is, let's say, employees and department. What are we going to use to join them together to the department ID? So everything in both left and right will be selected in that regard. Now, the cross join is that they are doing a cross product. Now, in this case, both tables might not necessarily have a column that you are using to match. So in real sense, in real life, they don't usually use cross join per se, but might use it as useful because they don't usually use cross join. So what cross join does is that, let me see if we can do. Sorry, this. Let's see if I can use my whiteboard here. This is good. So, okay. So, what is this? So, okay. If I have table A, and table A has these rows A, B, and C. Then I have table B. Then table B has maybe X and Y as rows. If I'm doing A cross B, that's a cross join, you are going to have how many records? This one has 3 elements, which is 3 rows. This one has 2 elements. So in this case, you are going to have 3 times 2 records for the cross join, which is 6. So what you're going to have is that you're going to have A is going to match with X. A also is going to match with Y. Then you go to B again. B is going to match with X. B is going to match with Y. Then after this one has exhausted the whole of B, C again will match with X. C will match with Y. That makes 6 records. 1, 2, 3, 4, 5, 6. So that's what a cross join is basically going to do for you. Now, it might not really make sense using it anyway, but in some cases you might have to use it. So this an illustration of doing a full outer join. Sorry, someone is unmuted. That Dr. Abel. Sorry. I want to mute you. Sorry. So full outer join. So I think I've explained that. So let's say look at this illustration. So select column 1, column 2 from table 1. Then I want to do full outer join table 2 on. Then you have an on clause where you're going to state which column are you using to join this table. So if you're using a particular So if you are using department ID, let's say table 1 is department, table 2 is employee. So you want to join them using department ID, then you can have something like, okay, table 1 dot department ID equals to table 2 dot department ID. You are saying that join it on where you have them to be the same, where it matches. Then look at the code join here. You say select start from table 1, join table 2. There's no condition. There's no condition. So this one just does a code join for you automatically. Another way you can do a code join without even doing this, I can say select start from table 1, comma table 2. I think that should also be a short join for you. So, okay. Okay, we have here 5 best practices. So the best practices involve use of partitions, dividing data into small partitions to make it manageable. So what we are saying is that in Hive, any query you write, HDFS, as I said, HDFS, Hadoop is using in Java and is majorly because of MapReduce. So if you write any SQL-like query in Hive, all the queries are being converted to a MapReduce. So at the back end, the queries you're writing are being converted to MapReduce. So they are running like a MapReduce job. So the rate at which query is going to run is going to be relatively higher as the way your queries return results in normal relational database system like your MySQL, your Oracle, your SQL Server. So that's why it is advisable to use the use of partitions. So you can, if you have a particular, let's say you have employees table. No, let me say employees table. So let's say in retail now you have some information about your stocks and all of that. So you can partition that table into products, using products or maybe categories. Okay, category for maybe beverages, category maybe like what category can you have? Like I think you get what I. So you can have maybe in that table you might have like 1 million records based on the different kind of products you have. So by the time you break it down into categories, partition into categories, let's say the categories you have in your supermarket is like 500 categories, or maybe 200 categories. So you'll be able to break that 1 million records into 200 categories. So each categories have different records. So if you are writing your query and your query just needs to return records based on a particular category, then your query does not need to run a scan on all the table, which is the whole 1 million records. You just have to go into the specific category that the records need to just return those. So instead of having to run on all 1 million records, maybe you just going to run on maybe 100,000 records. So that's best optimize your queries. And also the normalization. Hive does not require normalization to avoid complexity. Efficient use of single scan. So using single scan for all queries is also efficient. So what we are trying to say here is that to avoid the use of nested queries. So what do I mean by that? Like writing is selecting inside another select. Like you say select from, then you have another select from. So we have 1 million records, for example. Doing select start from it where this, then you are writing another select. This so you having select inside another select, then that's like you are doing a double scanning and all. So everything is being converted to MapReduce job, and it's going to increase the number of the the time is going to use to return the result. Also, use of bucketing. I think bucketing is what I will explain that time. Having used to split your data into separate buckets like categories. To distribute data into user-defined clusters using hash codes. That's more of like what I talked about partitions and all that. So so apart from this point, effective use of compression is also one of the Hive best practices. Let's see the next slide. Okay. Now, performance tuning is what we call performance tuning and query optimization. Saying query optimization has to do with your creative skills in writing query. So some people might write query and it will run for like 24 hours, and if you look at the query, you like these things are not really necessary. You can do it this way, you can do it this way. And by the time you remove some things that are not really necessary, one thing about writing SQL is that you might know how to write SQL. But having to write everything and try to make everything one at a time might make your query run at a very longer time and make your results return at a very longer time. So sometimes you might have to just break your script down into like 7 different parts so that it will save you a lot of time. So there was a script that someone created, and it was like like over 24 hours. And by the time we look at some stuff and change some things there, the query didn't run for up to 1 hour. So that's what we call query optimization. Then we have what we call the explain statement. So the explain statement is also used in my SQL. So what it does that, okay, after you go written your syntax and all of that, you can say explain, then into brackets whatever query you are running. Then this is going to give you a kind of explanation of kind of query you are running. You can have simple query, you can have nested query. I'm going to see the information. Then what you are going to see inside the explain command is abstract, syntax tree, different state dependencies, description of each stage. So it gives you like, okay, for each select statement, what's it like, simple statement and all of that. Okay, what are the dependencies? Maybe a particular select statement depends on what a particular select statement is going to return, like a kind of nested query and all of that. So the limit command restricts the output to a certain number of rows, but only after it has processed the complete result. So to optimize this, Hive allows setting of some parameters that are shown in the table. Where I think in this, you have to go to the hivesite.xml, like the configuration settings, you set some parameters there. So like the parameter you are seeing here allows sampling on limited set of files instead of complete source files, and cite the maximum number of rows limits should consider while executing a query. So I can say, so normally if you say, okay, select star from employee, then limit 10, you need 10 records. Now, I think by default, so if you have 230 million records, if you do select star from that particular table that has like 230 million records and you say limit by 10, first of all, it does a full scan. So it goes through all that 230 million records. They now give you the first 10, and that's not really cool. So here, what the edge you are giving here is that you can say, okay, my limit clause, don't let it do no more than 110 30 or 1,000 full scan before it returns a particular row. So by the time it's set it to be 1,000 rows here now. So if you do a select star from a particular table and say limit by 20, instead of going through the whole 230 million rows, you just look at the first 1,000 and give you the first 10 rows. So in that way, you'll be able to optimize some things in your select statement. Also, this last one, you have i.limit.optimize.limit.5. This one is saying, okay, decide the maximum number of files being sampled to run the limit query. Being sampled. Okay. So I'm not really catching this one. Okay, I think this one is just like saying, okay, shouldn't run more than a particular table. You shouldn't sample more than a particular table, maybe like 3. I want to join some kind of maybe 3 tables together or 5 tables together before you and want to limit at particular time. So this one can say, okay, you can't sample more than some specific, if I say 5. And it's just like you are trying to do query optimization, also performance tuning. So that's just it. All of these parameters you're going to see it in site.xml, the config file. So the last slide here. So various execution types. We have local, parallel, indexing, speculative execution. Let's see this guy. It says setting hive.exec.mode.local.auto to true enables Hive to decide about the need for a local node execution. So maybe you want to, your queries to run on local. Also, Hive breaks the job into certain stages that are executed sequentially. So set this hive.exec.parallel to true enables a parallel execution of certain stages of the job. So all these parameters certainly can be found also in your hive.site.xml. So while Hive allows creation of indexes and columns to accelerate the execution of group by command, it allows speculative execution of jobs by setting parameter as given below. Here, this first parameter runs more than one instance of map tags. This one runs more than one instance of the reduced tags. So here, creation of indexes just helps you optimize the time you use to return your results. So the advantage of creating indexes on a particular table is that let's say I want to do that, just say they group by or join and the like. So if I have a table and I index a particular column, say ID in that particular table. If I want to do anything related to that table at that ID, so you indexing ID means that maybe almost anytime you are working on that table, you make use of that particular guy called ID. So indexing that table ID is going to make your query run faster, because if I'm calling anything from that table and I'm using index, let's say I want to join a particular table and that table using that index, that ID, it just goes directly to that column and you don't have to look into all the columns before you can find the index. So not like you are trying to know the guy. So the DBMS has identified that guy. So the guy has been identified. So just like your library too, to you have section and everything. So everything is being indexed so that you have to do a full scan where you can get a particular book. So that is exactly how indexes work also. So, so I think that explains this part, and I should say we just have one more slide. Do we have any question before we move to the next slide?
I don't have any question.
Okay. Yes. So here we have file and record format. So we have the file format, which is text file, input format, and the output format. And you have a sequence file, then so what is the output file again? So the record format set holds the logic to convert constructed data into records and is implemented using Java. Oh, so in addition to regex and Argo set JavaScript object notation JSON, the standard format that uses readable text to translate data objects consisting of attributes. The material data is going to this guy. Okay. By habit. So okay. So as in the file format, so when you create a table to be stored as a text file, the input and output file format are as follows. So app.apache.hadoop.map, where this means map with the text input format. Then the output format is, as you can see here. Also, you have sequence files. So sequence files support block and record depth compression that helps in minimal disk storage utilization. And input output reads and writes also. That's IO. And so RC file is a record columnar file format. These are data placement strategies that help make decisions about efficient storage of relational data. So they are designed for fast data load, fast query execution, efficient data storage, and data disk. It's just like the format of your HBase, your HBase tables. So record columnar file format. So that you have a easy, fast access to load data into the environment and fast query execution. So, and that's also characteristic of the HBase tables also. So talking about the record format, you have the regex set. Record is set. Record format called set also. So you have the regex set. This majorly stores to create a table, you can. So if you are creating a table, you can store it, say, The row format of the table can be stored as we just said. So and if you are creating an average set, so the average set format allows users to read or write average data into tables. So we can read about the format of all these records. Or the most common type we work with is the text format. Then we have the JSON type of format also. Then I think the last one we have the thrift. So the thrift, we have what called the if thrift service. So the thrift format also, the ORC, I didn't talk about the ORC here. Talk about the ORC. So those are just the type of formats you can use to store records in Hive, but the most popular one is the text format in it. So let's look at the next slide. Okay, this one talks about the features of JSON. So read files stored in JSON format. Support complex JSON such as array and maps. So array is just the kind of matrix kind of format form of data. And when can you use something like that? So, can you use something like that? Maybe you want to store information about products, you call the call products. Then you can have corresponding column that going to have information about different products or maybe categories, say beverages. Then you can have information in an array kind of format. Then you have maps. So these are corresponding to the data types you have in Hive. Then you have maps. Maybe in this case you can have a particular department, job title, then the corresponding salary. So it's just like key value there in maps in this case. So you can have job title and the corresponding salary that the person can earn in that level. So maybe it's maybe data analyst in a particular organization, their job salary range. So maybe salary title, job title and sub salary. So maybe the range is between 200,000 to 300,000. So you have analyst, which is going to be the key. Then the value is going to be 200,000 to 300,000. So also it supports nested data structure and convert process data to JSON record using insert into. So we can read more about JSON format, and here talk about the if thrift service. So if thrift service here. So if thrift services are run on Hive thrift server, to which the following clients can connect. It's just like Oracle database now, system. You have what called the Oracle set, which provides clients with format we can use to connect to Oracle. So in that case, you have the Oracle clients in that. So this one, I think we have like 4 clients: the JDBC, so Java database connection, the ODBC, ordinary database connection, can connect with Python and PHP. So this one is just showing where you can build this sample JDBC if Hive thrift client. So as usual, I got to specify the driver name, the Java manager. So this usually data engineer is going to be the one doing things like this. If you really don't understand Java, database connection. You cannot write your Java client kind of connection. So, like my SQL too, if you are installing my SQL, you have different ways you can connect to my SQL. I use Python connector. I think you have Java, C++. You have my SQL for Excel, different kind of connection. So here I think you have like 4 of them. So yeah. Okay. Then talking about security in Hive. So Hive security is primarily a matter of 2 concepts: authentication and authorization. So authentication is more of like issuing password and likes of that. And authorization is more of like privileges. So all of these, you can, more authentication can do that, I think, in the configuration file for Hive. So setting hive.files.format.value sets the default permission for newly created items, while setting hive.metaStore.authorization.storage.checks true examines whether the user has permission to drop the table in Hive. Likewise, authorization can be added in Hive. So these are privileges and these are the description. Now, all privileges means for a particular user, let's say someone has created a user for me, maybe Ima, they have created a user called Ima, and they gave me all. They gave me is all privilege. So in this case, I can do or undo on that particular database server, not on that server. I can do anything. I can create another user. I can create table. I can drop table. In fact, there's nothing I cannot do. Now, if they give me create access, create privilege, it means I can only, if that's only what they gave me, I can only create tables. If it is drop, it means I can only drop tables. If it's alter, I can alter tables. If it's index, I can create index on table. If it is log, this privilege to log / unlock tables at the time of concurrency. Select, this one is that you can only select. And this is more of like the access they give they give consultants when they maybe come to consult a particular organization. They more like give them a select privilege on their server. So you can only select, just like you can only see. So that you are doing window shopping, you go inside supermarket, the only see that you can see. If you don't have money, you cannot get. So it's more like the select statement. You can see. Then you can select and pick something that you want. You can, that's what I put it. You can select, then can transfer, but you cannot change whatever is inside your server. You cannot alter, you cannot do drop. So that's more. Then you have updates, just figure to load or update table and partitions. Okay. Then this is summary of this session. So the most common operation in SQL is select statements. So 2 types of functions: the built-in functions, the user-derived functions, and a variety of built-in functions. We have the arithmetic, mathematical function, and built-in function. Then, so here we have Hive to support the limit clause, support nested queries, use case, arrow like and like, support joining of one or more tables together. Okay. So Hive join all tables together to get its evaluate functions. The various joins Hive supports are as follows: is inner joins, then outer joins, and you have the cross join. So mark side joins are recommended when you need to join two tables in which one table is smaller than the other table. Concept of partitions is in Hive helps in maintaining a new partition for every new day without too much effort. So you want to partition your data sets based on day, based on day. You have a transaction data, and you want your data to be partitioned for each day, so it can get this transaction for a particular day. So Hive does not have any primary and foreign keys because they're meant to not complex relational query. So by keeping the generalized data, you avoid multiple dig6, which is generally the case where there are foreign key relations. So Hive does a complete table scan to pose a query about that. Bucketing, like you can try to split your data into separate buckets. So compression of data on HDFS makes data smaller to query on, which helps reduce the query time. And we have the explain statement, which explains the kind of query you run. So in the explain command, we have these optional parameters. You can say explain extended, explain dependency, depending on what you want it to return. So you can decide not to put them, they are optional. You understand what the limits and the creation of indexes and all. So without wasting much of our time, I think we are done with this, and I will also request us to go through our material. It's very essential because the slides might already touch everything per se, like in depth. So we should take more of our time to go through them. And there are so many websites where you can get some practice question and questions on that. I also, I think we should, can I browse the websites I can share with you guys on WhatsApp. So let's look at analyzing data with Pig. Okay. Yeah. We have like 3 slides here. Let me look at this one here. I have like 2 slides. Hopefully we can finish. So here we're going to talk about discuss features and advantages of Pig, explain properties of Pig, use Pig Latin statement and function, use relational operators in Pig. Now, okay, this is going to take time. So let's look at the intro to Pig. So the MapReduce model cannot handle enormous data sets very well. So for execution of huge volumes of data, a feasible solution is Pig. So you can underline this statement. For execution of huge volumes of data, instead of using MapReduce, you can use Pig. Pig is also programmed using Java. So Pig programming language can handle structured, semi-structured, or unstructured data. Pig is a scripting language developed to automate the process of design and implementation of MapReduce application. It's easy to code and maintain. Let's see how that goes. As an optimizer that helps in smart data processing. So moving on to the next slide. So this talks about Pig Latin architecture, which consists of Pig Latin and Pig Latin compiler. So talking about Pig Latin, so programming language for Pig is known as Pig Latin. That's programming language. It allows you to read to write data processing and analysis programs. So it operates on language layer of Pig, and it describes a DAG in which the edges depict data flows and nodes depict operators that process the data expected. So like a data flow language. So everything we talk about what that is in when we talk about when we talk about machine learning, I think Bayesian network and something. I remember. So I say where the edges depict data flow. So data flow control language. So here talking about Pig Latin compiler. So compiler is just like maybe let me put it in. So let me Susan as a Yoruba lady and me from Portugal, I speak Portuguese. Then if I should write Portuguese and send it to so I might told us like kind of interpreter or some stuff like that. So compiler is like it compiles like makes Latin code, it converts Latin code to like executable code, something you can execute actually. So moving to what we call the Pig Latin compiler. So Pig Latin compiler converts the Pig Latin code into executable code. So these codes can be executed as a map produce jobs. Also, a process where a virtual Hadoop instance is created to run the Pig code on a single node. Let's see the next figure, which is the relation of Pig to Hadoop ecosystem. Then here we are going to have something like here, Pig Latin compiler, then processing framework, we have MapReduce and TES, then the source management, Yarn and MapReduce, then which is also system of the HDFS, which is the distributed storage we have in the Hadoop ecosystem. Okay. Now, talking about advantages of Pig Latin. Say it enables programmers to easily write, understand, and maintain complex tasks in parallel. So it's especially encodes complex tasks having interrelated data transformation as like a kind of data process. So it's kind of encodes a complex task to come like kind of interrelated. Okay, if step A, then step B, then step C, like follows a particular flow. Then you have what we call optimization opportunity. So it encodes tasks in such a way a system can easily optimize the execution. So it means big Latin also helps with optimization, so extensibility. So it also allows programmers to also easily create their own customized functions for special purpose tasks, because that's the essence of also if you are using a particular programming language and you can kind of explore and design your own function to perform a special task for you. So you be kind of limited to some. So that's the essence of using a particular programming language, because there might be some special tasks where the inbuilt function are not designed to achieve that task. You should be able to create your own customized function to achieve that task. So you have ease of programming, customization, and extensibility, which you can maintain. Okay. I've said earlier, Pig programming language is written in Java. So it supports Java properties and uses the Java notation. Here also, in an active peak session, the Hadoop properties can be specified with the D option and the peak properties with the P option. So if you want to specify the Hadoop property, I use the -d, then -p for the peak property. So the set command can be used to change individual properties in Grunt. So Grunt is just like as you will get to again. The storage for peak for this can be. So the peak Latin properties supports the following precedence order. So you have the peak D peak property less than P properties file and the set command. So D, which is for the Hadoop properties, and P, which is for the peak property. The peak does not interpret the Hadoop properties that are directly passed to Hadoop. And we have the Hadoop properties will follow this particular precedent. First of all, we consider the Hadoop configuration files before you Hadoop property, then P properties file, which is related to P, and the set command. Okay. And what we can do the next thing that should be running peak. Let's see. So this table shows the available properties of peak. Also, that's the property called bubbles in the static peak configuration file. This describes the capacity of output. By default, it is true. Output can be set to true. We have the brief property description brief output. By default, it is false. We have the opt.multiquery. This disables multiquery. By default, it is false. Stop on failure determines whether to terminate at the first error, which by default is false. So it means if you write the program and it's a step-by-step process and there's an error at maybe sounds like you don't just want it to terminate and just want it to continue. But if you want it to terminate at the first error that occurred, then you can set this to be true. Then we have the peak.no split combination. It determines whether small files are combined into a single map. By default, it is true. Then refer to the student guide for complete listing of peak properties. That's going to be inside our material. So running peak, we can run peak on local mode. So there's a peak acting statements and peak commands can be executed in various modes. Say local mode, so it can be run on a single machine without buying Hadoop MapReduce and HDFS. So this can be useful for developing and testing peak. So local mode does not require Hadoop, so like running a local system. And to run the peak scripts on local mode, say move the peak TMP directory execute the following using either script. I expand I look out the speed of this. So to specify peak, they want to start running peak, then type in X local, specify as local script one, I can local dot peak. So this first local specify that I want to run on local. In case you're using test local mode, then instead of local here, you are going to have test underscore local. Okay, yeah, more kind of, let's see. So here you can see running peak. You can run it using the code terminal. Like this is the terminal for it. The pig script embedded pig Latin. They have the pig Latin compiler. After you run uh your your, your code is passed into the compiler, then it's going to run maybe on local or in the Hadoop cluster. And finally, on this slide, okay, this is talking about local and MapReduce mode. As you can, as explained, as I explained in the previous slide, local mode does not require Hadoop. So MapReduce mode is also known as Hadoop mode. In this case, you're running on Hadoop. Here also can run on a single machine without requiring Hadoop MapReduce and HDFS. But in MapReduce mode, pigs executed on the Hadoop cluster. Then this can be useful for developing and testing big logic. What you're just saying in essence is that I'm running on local, just like I want to test track. Let me see how this works out before I move it to like generalization as we go into the Hadoop, running an Hadoop cluster. The local mode, the big program runs in the context of the local Java virtual machine. So in local mode, data access is through the local file system of a single machine. The local mode is a separate process outside the Latin. Here on the MapReduce mode, the big script gets converted into a series of MapReduce shells that are then run on the Hadoop cluster. So that's when you are working on Hadoop mode. And let's see the next slide. Okay, this one is talking about running pig in MapReduce mode. Pig can also be run on test. We've seen that in the previous slide. So run the pig script in MapReduce mode, you do the following: remove the pig TMP directory, copy this file from the TMP directory to the HDFS directory. And this is how you do that. This is how you do that. So you copy from local. So you have Hadoop FS, which is file system. So this one is saying that I want to copy from local this particular file into the Hadoop file system, which is the HDFS. And so you can set the big class paths, export the big class paths. Then if you're using test, we also need to put test configuration directory, which that is the directory that contains the test, the configuration file for test. So all the configuration files are written out. So if I say pig configuration file, you're going to be thinking of pig.site.xml. We are talking about the test configuration file, test-site.xml. So these are the way their configuration files are built. Okay. See the next slide. So here you're going to set Hadoop configuration directory also. So to the location of the cluster configuration directory. To export this guy to this directory, then execute following command using script1-hadoop.pip. It is different from the way when you are running on local. As you can see here, specify pip that you want to run pip. Then specify script1-hadoop.pip. In case you are using text, you are going to use this -x. When you are doing on local, you have this -x. Just have to take note of this thing. So here, okay, here is like review the results files located in the script1-hadoop-results or this. So if you are running script1-hadoop, you are going to have the results in script1-hadoop-results. So if you want to review it, we are going to Hadoop fs because it's going to be stored in the Hadoop file system. Then -ls means that I just want to like see this particular file. Like I want to see it. So if I should put this cat, if I put this cat here, it's like okay, I want to print what is the content of this cat. And see the next parameter they set here, the next thing they listed here. I don't remember. Okay. So if we have a Pig Latin application flow. So Pig Latin is a data flow language. In Pig Latin, a data stream is defined and the series of transformation are applied to the data as it flows through the application. So a data processing data flow is illustrated with load. So A is equal to load file name, B is data processing operations, can be group then you say dump B, store B into. These are the process. Okay, process A, I load the file. Process B, I perform some operations, then dump. Then I'm done with B. Then I want to store B into this particular file. So a dump statement is to view results of a store statement to save the result. Dump is just to view. And store statement is to save the result, as you can see. And the load is to read the data from a file system. I think I've talked about this load statements. Then the second part is called transformation statement, where you whatever thing you want to do on the data, then dump to view, store to save the result. Okay. Beginning with Pig Latin. So Pig Latin is the syntax of the language for Pig programs. Pig translates the Pig Latin script into MapReduce jobs that can be executed within the Hadoop cluster. As we have been saying earlier on, like almost anything you do on the Hadoop ecosystem is going to transform into transform to a MapReduce job and doing that. So while developing Pig Latin script, follow these design principles. Keep it simple. So keeping it simple, make it smart, and don't limit development. So keep everything you are script you're writing as simple as possible, make it smart, and also don't limit development. So make it smart. You may recall that the pig Latin compiler does not work, does the work of transforming a pig Latin program into a series of Java map-reduced. SQL is set up as a declarative query that you use to access structured data stored in the RDBMS system. So let's highlight this guy. SQL is set up as a declarative query. Something like this might come up in the examination, just in case. So don't limit development. This refers to the principle of making big extensible so that developers can add functions to address their particular business problems. So that's the essence of you creating some special functions and user-defined functions for Excel. So talking about big data types. So this makes up the data model for how it thinks the structure of the data processing. So any data loaded into big is going to have a particular schema or structure. So it needs to understand the structure when you do the loading. So the data automatically goes through a mapping. So here you have scalar types and complex types. Now the scalar types contain a single value, and the complex type contain multiple values like your tuple, your arrays, and your maps. So your scalar type that contains a single value be like your integer, your decimal, floats, and the likes of that. Let's see. This is the next element. So Picard has the following 4 types in its data model. You have atom, tuple, bag, and map. These are more like the complex types. An atom is any single value, such as a string or a number. So this one is the scalar kind of data type, like your integer, string. Tuple is a record that consists of a sequence of fields. Each field can be of any type. So tuple is just like I don't want to say a list. So there's what called tuple. It contains elements in closed brackets. So it can contain integer, can contain string, can take anything. So then you can see it as a list also. So a bag is a collection of non-unique tuples. Each tuple in the collection can contain an arbitrary number of fields, and each field can be of any type. So a bag here can be considered as a list in R. A list in R is like a basket that you can put anything inside. You can put vector inside, you can put matrix inside, you can put data type inside, and all those vector, matrix, and data and data frame you are putting inside can contain elements of any length, can contain rows of any length. So you can see back as a list in R. You also have a map. You have explained what a map looks like key value pair. So it's a collection of key value pairs. So any type can be stored in the value. So any type can be stored in the value, and the key needs to be unique. So the key of a map must be a char array, and the value can be of any type. So let's take a look at this. I say saying that the key must be unique is that if I have a map and I have a key value pair, say let's say the key is employee, then maybe the value is Dr. Abeg. Now for another key value pair, you shouldn't have what we call employee again. Let's say employee, then you have Susan. So you cannot have employee again as a key. So that's what we're talking about here. So these are atoms, as you can see here. So these are atoms, these are Take over atom back. Now atom, as you can see here, as highlighted here, you have numbers 2013, 2013. Like a single, this is called like a single row, like a column, in data frame. So it can only contain a data kind of data type. There is integer, string, dates, and bytes. Now, as you can see, atom can also be a char. But bag, as you can see bag here, bag is like everything combined. It combines atom, it combines tuple. It can, as you can see to your right, so it can contain a map. So you can take anything. Now, tuple is one that, okay, you can see here, you can see these old rows, this old row here, like a tuple. So it can contain integers, as you can see here, it can also contain a char and in row form. So let me put that one. Now map, as you can see map here, you have the key, you have the value, you have the key, you have the value, you have the key, but the key has to be unique. Then values. And your key has to be char. Also. I believe this is properly explained before we move to the next slide. If you have any question, you can this. So simple, and let me say simple. So the basic things, should I use basic? So all these things that we can easily grab and understand, so we should really take note of it. So can we move to the next slide?
If we have to.
Okay.
All right. So moving to the next slide here, I talking about peak syntax. So peak implementations have lesser codes that are easier to understand. They have powerful syntax, simple syntax with powerful semantics, which are used to carry out the following operations: access data, operations like load, store, and stream data. Also transform data, which involves operations like grouping, joins, combine, split, filter, and sort data. So let's see the table that gives an overview of the operations associated, operators associated with each operation. So here, data access. So you have the load/store. Load is to read and write data. The store is to save. So load is to read and write, store is to write. Yes. The dump, write output to standard output. Is like what dump is just like that kind of print or something. And stream sends all records through external binary. Transformations that are like for each, filter, join, group, other distinct, kind of a lot of them. So for each applies expression to each record and output one or more records. So it's like you're doing it for like you're looking through each record in a particular table. And filter applies predicates and removes records that don't meet the particular condition. So I can say, okay, filter by age. So age greater than 20. I just need information about some people that are age are greater than 20. Then joins to join two or more records on a particular condition. Describe. So you have the debug operation also. So the describe, it turns the schema of the relation Like in my SQL, you describe table, gives you the column names that you have with that table, data type, can it accept a non-value, is there a primary key, is there a default value to a particular column, and all that. Then dump the contents of the information to the screen like a print. It explains, it is the map reduce execution plan as you have in the hype also. So peak program can be packaged in the following 3 ways: scripts, grants, and embedded. So scripts, this method involves saves a file containing peak Latin command by the .pig suffix. So for any code you write in pig, then you save it as script, it's saved as the .pig extension as you have in my your relational database, stored with .sql, your Word document is set with .docx like this. So grunt acts as a command interpreter where users can interactively enter pig Latin. So it's just like an interface, a command line where you can write pig program. So 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 can directly enter pig Latin at the grunt command line and immediately see the response. So just like your command, the way you have your command line in say command prompt in Windows, they also have grunt in it. Embedded, pig Latin statements can be executed within Java, Python, or JavaScript programs. So pig scripts, ground shell pig commands, and embedded pig programs can run in either local mode or map inputs. Something like that, I can write pig statements in Python, Java, JavaScript programs. So let's look at next slide. Running pig in local mode, we can so you specify okay pig, specify pig, then -x, then local to tell okay I run it in local mode, then you specify the scripts you want to run. So this name of this script is mouse carrier.pig. So by default the pig script runs in Hadoop mode and can also be specified in the command as well. So even without me putting -x map reduce here, if I should run it, it's going to assume like I'm running in Hadoop mode. We want to explicitly specify that I can do -x map reduce as you can see in Hive also. Then specify the script I need to run. Okay. Then scripting with pig Latin. Hadoop is a rich and quickly evolving ecosystem with a growing set of new applications. It's designed to be extensible to UDFs. UDFs can be written in Java, Python, or JavaScript. I think if you have some people that are very good with Python, that's why they are UDFs in Python instead of in Java. Maybe I would have preferred writing in Python. So some of the big UDFs that are part of repositories functions like data time, date time functions, text, math function, and start function. So that's nice. Standard UCFs are written in Java and packaged in Java. And executable UDF is created by creating a Java containing the UDF class file, as we have seen in Hive also. Create the Java, then specify the directory, the location where you are going to save the Java, and you're going to create your function right there. So to use a UDF in pig Latin program, this one needs to register the jar file with pig using the register statement. Here you use register statement. So when it is registered with pig, so it can be booked by calling its Java class name. So, for example, piggy bank has a UTF. See, oh, this people know about piggy bank. Upper function. The upper function can be used to transform the string to upper case. So, first of all, you register uh, piggy bank / Java / so this is directory, and this is the jar file piggy bank jar, and say b is equals to. So this is when you are creating a let me see. Okay, yes. So b is equals to for each a generate org.apache.pig dot your your jar file created dot convalidation dot string. What do I have here? Then let me see. This is what I have in this file. I start to do. Yeah, we. Okay. Okay. Sorry. Dot. This statement continues here. Dot upper. Specify this. This is where you are creating. So this is supposed to be where you are creating the upper function. They didn't define. If you want to create the upper function, you have written a line called define upper. Then you write whatever program to convert a particular string to upper. So something we have followed here dot upper. Then afterward, then you can use it in a statement. Say b is equal to for each a generates upper stuff. So this there is a misconception in this line. Okay, let me see whether they explain this in the next slide. So as you can see here, while executing some programs, the UTF needs to be called multiple times. There's a defined statement in the previous slide where you are going to define to assign a name to the UTF which has to be called multiple times. So that's where you create a class. So this is, as you can see here, define the UTF you want to create. Then this one does the whole creation of the class. So by using the define statement, user can avoid writing the fully qualified class name every time you need to use the function. So instead of having to write all of this Apache pig blah 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 blah, we are giving the name called upper, so I can just use this guy. So here, let's do okay. For each a generate upper. Then this will give me the upper class of all the records of A. So that will be assigned to one variable called B. Okay. And I need like a 5 minutes break, water break. I want to take 5 minutes water break. Am I permitted?
Yeah, you are. Come back 5 minutes.
Thank you. So I'm back. I'll be still. I'll stay there.
Welcome back.
Hi, Susan.
Manuel. Yes, I'm here.
So talking about writing to start defining function. Uh, here, here, the obviously now we're going to be writing this in Java. We might not necessarily have to maybe talk about most of this. Let's just talk about some basic things. So this supports the following categories of VGFs. Eval. Most CDFs are eval function that accepts one field as input and return another field as output. So what does that mean? It means taking something and I give you something like just like normal function, Like your grinding machine takes in paper, it gives you something like a grinding paper. so that's eval. So load slash store. So the load slash store functions are used only in load and store statements to help you read and write special formats. So a UDF can be written using its Java API. So the exec method processes the tuple and returns the type C corresponding to the valid big Latin type. I think the exec should be used to execute a particular function. Okay, let's see this one. So the best methodology to create a UDF is to first start working with a similar UDF. It is then advised to customize the UDF as per requirement. Some UDFs that call for special considerations are filter functions and aggregate functions. So he said eval functions such as filter functions return a boolean such functions are used in big Latin filter and space statements. So what they're trying to say is that okay, you want to do a filter. So if the reason I say such filter function return a boolean is that if a particular condition is met, you're going to return true. If not, false. So it's like we got a kind of Boolean statement, like Boolean result. Okay, it checks the particular function. If it is true, that's in return. So Boolean is just true or false. So aggregate functions, about functions such as aggregate functions are another example of such functions. So aggregate functions are implemented on grouped data, like using the group by class elements. And let's see next slide. We also have parameter substitution, whereby you are the way you wrote the function is whereby you can it's dynamic such a way that I can prompt the user to fill in an input and turn an output as a result. And if you are writing user-defined functions, so parameters are used to place. Okay, you have to put in something. Okay, maybe I want to create. So let's say I want to create a function that's going to give me the salary, the information about employees that their salary is greater than a particular salary. So here, my input is going to be that salary that you are. So the way I'm going to create the function is that it's going to accept a particular salary you want that's the salary range of those employees want to return will be greater than it. So let's say I want the result of employees that are salary range, a salary is greater than 200,000. So in that case, my input into that function is going to be 200,000. So by that time that function I created accepts 200,000, then that's going to return and those information of those employees that their salary is greater than 200,000. So that's going to be a parameter in that function. Also, relational operators in big. So relational operators in big Latin can be used to transform data by filtering, grouping, sorting, and joining. So for example, using relational operators like for each, so relational operators are that equal to, greater or equal to, less or equal to, and stuff like that. So basic relational operators for each filter, group, order by, distinct, join, limits, sample. So those are the basic relational operators in big. So when you talk about in MySQL and the likes of that, you have all of those normal arithmetic relational operators. Okay. So you have for each, I think we understand what for each actually does. Then filter does to return result based on a particular condition. Then the group that is to group a particular query or result based on a particular column. I think I've seen about the group by statement and stuff like that. And other by is just like sorting, like you are sorting a particular statement, particular result. You can sort by, okay, I want to return records of employees, but I want to sort the result by first name. By default, it's going to be ascending order, but if I want it in descending order, I can put this to ESC. Ascending is ESC. So you can whether be date, be it string or character or integer, ascending in alphabet, that start from A. For numbers, start from the smallest to the highest. For dates, it's going to be for dates, yesterday is lesser than today. Yeah, logically like that. Then distinct is to select unique elements. So select unique element. So it's really return duplicates. So that's the essence of using distinct. Then sample is to select based on, let me say, the sample operator can be used to select a random data sample by stating its sample size. So if I want to select from a particular table and I say, okay, I want sample size 100. So if that table contains 1,000 records, it randomly generates 100 records for me. So talk about the limits, talk about the join, and I think what do we have again? I think that's it. But let's not be limited by what we do, what we talked about. Class, we have to still fall back to our material and go through it. Take our time. Let's take our time with it. At least our first reading, we should really take our time through it. By the time we are doing a second reading, I know it's my look like it's a hold up. After our first reading, our second reading is going to be like glance through. It's going to be very fast compared to our first reading. Our first reading, we are trying to look into it line by line, line by line. grab as much as possible. Then there's going to be a second reading. Then you can have the third reading before you take the examination. Then you have done some practice questions, side by side with this also. It's also essential. So let's see. I think we still have time. So let's see. Okay, about Spark and Scala fundamentals. Okay. So today we should understand the difference between Spark and the Hadoop framework. Describe the key components of Spark ecosystem. Explain the Spark program flow. Work with basic scalars, constructs, and pre-program Spark. So let's see. So we are talking about the Apache Spark. It's a product of one of the projects of Apache project. Apache Spark is a new cluster computing platform designed for fast and general purpose big data processing and does not rely on MapReduce. So the following point makes Spark unique: Spark architecture, which enables storing big data of each part of data in memory and provides massive performance improvement. Spark programs, as a result, can be many times faster than their Hadoop counterparts. Speed is a key consideration in big data analytics, very essential. And why it is many times faster is that I said it enables each data parts, storing each data parts in memory. So whenever you are running in memory, obviously it's going to be very faster. So Spark's API and runtime architecture, writing distributed programs in a manner similar to writing the local ones, using functional programming methods which are very appropriate for data processing. But let's see more about Spark. Spark programs can be written in Java, Scala, or Python, but Spark is written in Java virtual machine language, Scala. Therefore, Scala is the primary choice of language, and with a command line tool, which makes programming considerably faster. Also, Scala is more versatile, flexible, and functional programming concepts are much better fits for data analysis. Okay, let's look at the next slide. Okay, let's look at some key issues with Hadoop as related to Spark. So as mentioned, the Hadoop framework with HDFS and MapReduce as key components was one of the initial frameworks that enabled large-scale distributed computing. So, but MapReduce, along with Yarn in Hadoop, to provide solutions for parallelization, that's parallelization of the computation, distribution, and fault tolerance. Also, all problems do not easily fit two-step process with MapReduce. The API can be bulky as well. Hence, a number of tools have been added to the Hadoop ecosystem to improve for importing and exporting data, manipulating data, and for real-time processing, which results in a complex environment because you have to add a lot of things and to make things really work out and flexible. But let's look at the Spark advantage. So Spark performance. The Apache Spark model is an in-memory execution model which allows catching of job data instead of fetching it from disk each time as with MapReduce. So that's one edge. Thus, While in case of Hadoop, you would need to store the result of each basis of a program on disk, which is the HTFS, and have the next phase with the result of the previous one from disk. But with Spark, you can cache the data of previous phases in memory and use the data for the next phase. This leads to considerable performance gain. So the edge there is still like in-memory computation. Okay. So also ease of use, Spark API is simpler to use than the MapReduce API. So look at this instance. To implement the classic word count, like count number of words in a particular file, you are from a MapReduce job, you have to need 3 classes. The main class that sets up the job, the mapper class, and the user class. But let's see. Platform. So Spark combines a number of the functionalities of tools available as a part of the Hadoop ecosystem in a single framework. So, and the execution model can be used for streaming data processing, machine learning, SQL-like operations, graph, and batch processing. So Spark also took the functionalities of several tools in the Hadoop ecosystem and just compile this guy into a single framework that can be used for different things at the time. So this allows for various tasks to be completed on the same platform and makes collaboration and functioning simpler for programmers, data engineers, and scientists. Okay. So Spark includes many purpose-built components, which we have Spark Core, Spark SQL, Spark Streaming, Spark Graphics, Spark Machine Learning Library. Yeah. So let's see whether we can talk more on all of these components. So the Spark Core, in this case, this is the basic components on which the other components depend on, just like you have the HTFS in Hadoop. So the Spark Core includes basic functionality needed for task scheduling, memory management, fault recovery, interacting with stored system. So this is just like what Ian does in Hadoop 2. Spark Core offers a way of sharing of information between. Yeah?
Are you still sharing your screen?
Am I not sharing my screen?
I can't see it anymore.
Dr. Ben, can you see my screen?
Not at all. And there's background noise there now.
I'm still sharing. But the funny thing is, I'm still sharing.
Check.
I'm trying to share it again.
What are you seeing exactly? What are you seeing? You're not seeing anything.
I'm not seeing anything. I'm just in a blank screen.
Oh,
My screen too is blank.
okay. Let me stop sharing.
Yeah, you try to reshare again.
Can you see my screen now?
Not yet.
Oh. You can't see my screen.
You know what? Let me. Dr. Ben, can you see that?
Not at all.
Okay, just give me 5 minutes. Give me 5 minutes. can do something.
Okay.
Sorry, I don't know what you're trying to say now, but let's use another system. I'll share my screen. I'll share my screen now. I think it can see my
Yes, I've come up.
Okay. I think I'm here. All right. So we're still under Spark architecture. Susan, can you see my screen now? Susan, can you see my screen now? All right. I think it's able to see my screen now. So here the Spark SQL. So Spark SQL enables functions for manipulating each set of distributed structured data using SQL as a structured query language and also SQL language, which is SQL. Spark SQL can be used for querying JSON data also, and also for reading vector formats. So Spark SQL offers a query optimization framework called sorry, okay. So Spark SQL offers a query optimization framework called Catalyst, which can be extended by customized optimization rules, as well as includes a thrift server, which can be used for external systems. Okay, so to query data through Spark SQL using classic JDBC or ODBC protocols, which are clients use to connect to databases. So JDBC means Java Database Collection, ODBC means Database Collection. And we have Spark Streaming. So Spark Streaming just gives you the edge for like a real-time retrieval of data, so like real-time streaming data from multiple sources, from such as HDFS, Kafka, and all other sources. Like it's used for real-time access of data. That's the essence of Spark Streaming. Also, we have Spark.x, data structure comprised of vertices and edges connecting them are known as graphs. So graph X component includes a library of functions for developing and manipulating graphs and application of some key graph theory algorithms. So that enables you to build graphical models. And I think yes, I remember we talked about graphical models and in machine learning. So also we have the Spark ML which is the machine learning algorithm. So library for machine learning algorithm is Spark to create logistic regression, base classifier, SVM, classical vector machine, decision trees, random forest, linear regression, KNN, that's K means clustering, and others. So Spark can eventually scale up to big number of compute nodes by running majority of cluster managers, including Atlassian. Uh, and the cluster manager created in Spark itself called the standard. So Spark ML actually enables us to use machine learning models, machine learning algorithms. Also, I think we are going to cover that. So this one The following questions are the best system. Talk about the type. Then we have this. So say if you compare the previous figure with the Spark ecosystem, Apache system can be replaced by Apache Streaming, Apache Jira can be replaced by Spark. So Apache system can be replaced by Spark Streaming, Apache Jira can be replaced by Spark GraphX. I can say that both of them they are really similar in similar format. So Spark LLM can also be used to instead of Apache MapApp. Apache MapApp also has machine learning libraries. So that's why they are similar. So Apache Pig and Apache Scoop are not applicable with Spark anymore. As the potential as included in Spark 4 and Spark SQL. However, you can still run Pig with Spark. But Spark cannot replace Hadoop infrastructure and hence, Impala and we can coexist alongside Spark. Then this we have the Spark support system. Spark. Yeah. It's comprises of two components in this here. Then so we said as we mentioned before, each data storage is not required in Spark anymore. Spark can also operate on data stored in Amazon and cloud. And use flash memory, which is memory matrix. So don't forget that Spark works in memory and you don't need the internet storage device. So Spark is also not required to run on here. The Apache methods and Spark and alternative cluster methods for Spark. Instead of Yarn, as we have Apache methods and Spark and the Apache methods is an advanced distributed system using distributed resources and can scale to big number of nodes with complete fault tolerance, which is one of the advantages Yarn is introducing in Hadoop. So if you have Apache methods also doing that in Spark. On the other hand, Spark cluster is a Spark specific cluster manager in production, particularly on multiple sites. Okay, that's for next slide. So here, talking about just a minute. Okay, now moving on. We are talking about installing Scala. Scala is started as a KVM using KVM for if you want to use Spark and you do need to use Scala as the libraries are in the distribution. We are we need to use them Spark as Scala as libraries in the distribution. Or if you want to write your own Scala program, you use part of that. This site here. And after I said that development, I think set part for the data and also access take an access program from the manager. Okay. You have Scala package import works in Java import.
Uh, however, instead of star in Java, use underscore. It discover the use of star application underscore. So say as far as is based on different important Java job partner. This is based with Java also. So let's look at the data types. So we know data types where the scala is byte, char, short, int, long, which all these type and long are just like include data type but they are just the number of decimal is paper. You have double, you have boolean, something like 2 of both. So these are classes and the Scala doesn't support creating data types like Java. So they are classes and use class method to manipulate them. So let's see. As in Java, Scala stores class and include multiple classes. These are used to create class, class, format class. But you don't have an identity for that. Let's talk about function and features. So the calling functions, must be the function called in Scala are similar to that in DASCA. The method name is called by using the dot notation to give so like if you want to call like so so like the print function in Power. So we have different methods attached to it. The method are just unique to perform some particular task. The print generally when you use the print function, it just this is how it actually works out. If I say print something, print checks the kind of structure for what you're trying to print and uses that method to print it. If there is a work that is actually doing under than but if you use it to a particular method, if I use something like print dot, let me show us something. Let me look my out to the print. So I'm going to try one first. Me is funny about it. So now it's very funny as your child. I think that very funny things. So let's say I want to create a vector. Let me the vector. Let me start with the vector. So let me say this vector. Then vector of 1. Then we need to put it. We need to out of 10. Okay. If I add this now, if I type this, it will give me the vector. Take it to the output. If I use print, if I use print BDC, for example, you just see the results. It doesn't give you the results like normal like this. But there's something like the results. So there's a method in place to say I think print by this print on default BEC. It's print. You just find the default that. Now there's another method called print. There are different methods attached to this. So if I say print dot data dot print and I pass BEC inside, you can see that it didn't return anything. It returned null. This method is designed particularly to print data frame. So at the back end, it looks into the argument and finds the method that can restrict these arguments you are trying to pass and give you an output. But this specific method is designed to change a data frame. I don't mean this guy is a data frame. This method will have work perfectly. So let's say let me try and convert this BC to data frame. This method is going to see the DF is as just data dot frame. Then I'll pass this to it. Now this has been converted to data frame. If I should use this in the data frame and change this data frame, it's going to just split it as you can see here because it's assigned to it's fit to some that specific part. So going back to our we have print, we have function, we have methods which is called by using the dot implementation of the So moving on, we have operators. The operators is scalar operationally most of the Java operators. Then control structures. In control structure, you have they don't support if, while, and for control structures. You can run the four kind of use to it. The if statement, while, and then talking about structure, the Spark has an interactive shell similar to an arg or Windows command which enables arg or ad hoc functions like our arg. And this is my arg to do. Arg to do is just a structure where interface saved by it's easy to program and so like that. But arg actually has its own commands magic like this. So if you want to learn how to do arg, I'll tell arg how to do. So arg uses arg. Because I use arg to have but I don't think I have I have I can see here arg. And this is what you are this is constant. This is arg. So I can do whatever I do on arg, I can do it here and then say this amount here. Yeah. Everything is one in line by line. And you have this. In the way I can see new script, then I can write my script there. Anything I write, I can say one, then start with this, and it runs on the console here. So just like that. So we also have Spark so in this case to run a command. Then you can you see all Spark application is built in Java inbox. It contains the application network. So this defines the distributed data set on the cluster and applies the I said we did one line count example. This is count the number of lines in the Java program was this shell. So the Java program access Spark using this Spark context. But we more about this. I think basically we are just used Spark and Scala fundamentals. You might not necessarily have to just have an overview of what Spark and Scala is. So talking about standalone application of Spark, Spark can also be used into standalone application in Java, Scala, or Python. So what you can take this from using it in the shell is initialize your own Spark context. But if you are still using this, okay. So in Python, you can post applications as Python script and then run them using this stack type of select script is stack. And sometimes I'm having to write an application in Python when it is stack. In this case, probably you have more confidence in writing this Python program rather than Java. Okay, then that should be all. That should be all. That should be all. One thing is that you just have to read more about all this stuff. If you are really interested in working with Spark, then you can read more about Spark. And that's it. So this time just talking about initializing Spark. This one is Scala, this is in Java. So here we are trying to do the word count program that will count the number of lines in a particular block. This is part of the program. This is writing it in Scala, writing the same program in Scala, and, and that's it. And that's it. So I think we have covered the whole of the 2 year also. But before we go in, remember I told us that I shared a particular link for us. There are several links we can actually do. I think the first one I shared is let's the icon is from the let me check this. Let me check. Okay. Data flare the changes. Let me just see this says. I'll just send the name on just go to data flare. I think so what's name about artist they have person and eyes fire. Let's go to the artist for example. So this is going to talk about I'm going to have practice question to practice question on architecture. So I just have to go to quiz here. So you can see here you have a lot of questions. Here. I will just click on this. See, they even have some kind of like kind of notes on their data. But let me click on this. Let me click on this. Why is it? Let me see one. Just again. Let me just edit this thing a little bit. I do not. I'll edit this guy. Say, big data, output. I don't have access to the name that I'm trying to do this. Part 1. This just directly to. You see on this same thing. Here you have this question, as you can see here. Big data this question and answer. Obviously objective. So you can have this kind of format, say which of the following is human value. Are we still on this call? Are we still on this call? Are you
I'm with you.
okay? Is Suzanne with us? Is Suzanne, are you there? I think Suzanne is doing something. So which of the following is the one of attribute name node manager data lead all of the above. So you can see that all of these are being done to all of the above. You can test your which of the following is first about attribute. It's distributed framework. Then I'm going to use this unit is marketing. It's not commodity hardware. Okay, contact you. They just have to test your memory and all of this. Azure framework is written in what? Is written in Java. So each of the following components is component of Azure. Yarn is Azure, HDFS, packages, all these things are Azure, all of the Azure. Just have to test your memory. It's going to be consumption. Archive files written in Azure has its destination. You want to check the status of all emails use KPIs. These are inside the lab manual. This particular time, you want to check process that are running. You might not necessarily see everything personally because they didn't really talk in depth about the other people. At least you get to answer some of these questions. So this is a particular test. The analysis is much. The instance will be able to do that. So, just one of these, I think that we have to choose question we have part two. So, you can practice, let's see, let me see the list. Let us have question on type, let me see data, the, we have question on type, type is, AI Apache algorithm, let's check. So you can see some is student application.
Let's go on. She will join us.
So here you see you can see the application on outcomes. The result of the high query can be stored as the local file, HDFS, notes, how to store. Since I is done doing on a do, if you going to store your it can be stored, if you store it in both local and HDFS. So if the database contains some tables, then it can be forced to drop without dropping the tables by using the keyword. If you want to drop a database and you want to drop the corresponding table with it, then you have to use the cascade table. But here they are saying that if the database contains some tables, then it can be forced to drop without dropping the tables by using the keyword. I think the answer should be this in strict. But why is it cascade? I say without dropping the table. If you want to drop the table, that's when you cascade. You only drop the tables. If you say just drop the tables, then you put a cascade. It's going to drop to the corresponding tables. I don't know why you put cascade in here. Maybe the question is somehow. So, so users can pass configuration information to the set using the set I think you have to know about the property itself, the I property. So I think it should be the answer should be the set property. Say with set property. But you just have to know about all these properties but then they might not really get more about all of this because but you just have to be there do these properties. So a lot of it here. What is the value of using too many partitions in I field? If we don't want to use too many partitions, we need to use too many partitions. I say it says storage space is wasted, joint query becomes all of the have. This should be all of the have because if you have too many partitions, all of these things is going to affect your theory. So also by default, when database is dropped in time, the inputs are also deleted. So the directory is deleted if you are not the HDFS blocks are formatted. Hmm. Hmm. If you drop a database, if you keep cascade, if you want to cascade, automatically all the tables there will be deleted. But you can't say sure that by default it does this. If let's say by default it does not do this, then the directory is deleted because when you create a table, when you create a database, you create a directory with it. So if you drop a table, a database in I, the directory also should be. So the directory is deleted if you are not able. Yes, it should be deleted if you are not able. So that would be the correct answer. So we just have to read more of this. I think we are going to define there's no word about it. See, let's look at this. The view in I can be seen by using is to show views. Show views. Why do you show tables? Okay, maybe show tables right. Maybe there's something like show views. Show tables. Views not like a table to show tables. You should also show the views also. So look at this question like there are some questions that are going to maybe get confuse you. So if you don't do all these things, you won't get it right. So now what is the key point or show this, which actually show table because a view is also like a table, it's like a temporary table. So if you say show tables, your views will also come along with it. So look at this particular statement. So practicing on this question also help you in a way, also help you in a way because during the exam, there's nothing like practice. They are doing it, they are doing it. You know what they are doing is not right. So let's look at this. If an index is short, so when we talk about index, say this makes very well faster. It's not an index, that's the person of question. If an index is short, index, you create index based on the particular column they come. If an index is short, the underlying table is also short. The directory containing the index is deleted. The underlying table is not blocked. Error is shown by I. This can be true. This can be true. We drop an index. That shouldn't be the. So this should be the case. The directory containing the index is deleted. wow, and see error is shown that E. So all of these things, but then we didn't this thing was not the material, but practicing all these questions also gives you an edge. Okay, let's see something that okay. Uh, so to see the patient's case present in an high table, the command used is now the answer can be this first one, which is the described. The answer can be this second one, which is described extended. But I don't think there's something like described extended. In your eye, you can only have one for explain. Then there are some optional parameters where I'm using the explain. That explain dependency, explain extended. So the interview what is described extended, but in this guy, so if this case is excluded, describe table as of that. Let's see what is this. Describe extended is correct. It means there's an extended keyword related to describe also. So that are things that will keep us updated. We don't just this and then and see we are going to lose points. We are going to lose points. I said which kind of things constraint it can have. Don't forget. Let us even remind ourselves. I think we did today too. That describe that we went through together. It told us about I not having primary or foreign kids. It means this answer should be none of the above. If you remember very well, they talked about this. So if you don't read them and do all these practice questions, we will be doing ourselves good. We will be doing ourselves good and don't just please out. So having to read our material line by line, first reading. After I've done a first reading, you can come here, do practice questions. There are so many surveys that have these practice questions. Some of the vowels you face, you don't have to, and what is at the end of the day. But you can see so many things that you can do this practice question. Do a lot of practice question, then do another second reading, then final reading and practice question. Then we'll be good to go. So let me stop real quick. I think that's send the message.